Welcome to qnawire.
So this question wants you to calculate the force exerted by a ball when it goes through a change of direction. So since this is a momentum chapter, we might as well just use momentum equations that we have. So you have a ball that's moving, let's say in this case to the right. It gets into contact with the bat, and then afterwards, the ball moves upwards with certain speed. So initially, it's going at 45 meters per second, and then afterwards, it's going at 55 meters per second, but there's a change in direction. So that means there was some force that acted on the system to change um, the direction of motion. So we know that forces are always equal to, so this is just the average force is just a change in momentum over some change in time. So in this case, you have a force that's exerting a force that's being exerted on the object is going to change in momentum after acting for a certain amount of time. So what this tells you is that if you have a change in momentum and you know how much time that force was acting, you can actually calculate what the size of the force was. So because this involves two different directions, we can actually just split it up into, so in this case, we can first calculate the force in the x direction, which makes this thing stop from 45 to 0. So to do that, we can now just calculate the change in momentum. So we know that the mass is 145 grams, which should be just 0.145 kilograms. And we know that the velocity changes from 45 to 0. So this change in velocity is going to be just a negative 45. So we know that this force was also acting on the system for 2 milliseconds. So that means that this denominator is going to be now 0.002. And when you punch that in, you realize that the force that's exerted is 3.3 times 10 to the third newtons. So this is the force that's exerted by the bat on the ball. But the question wants you to calculate the force exerted by the ball on the bat. So essentially, in x direction, you can just, since the third law says these forces are equal and opposite, you can just take on a negative sign to that force. So in that case, you have a negative 3.3. So this is initially negative because, again, we have a negative sign here. So this would be a positive 3.3 times 10 to the third newtons. And this is the force that's exerted by the ball on the bat. And then you do the same thing in the y direction. So you have to calculate your f of y here in the same way. You have the same mass. Now the change in velocity is different. So now the change in velocity is positive 55 because it goes from 0 to 55 because it's now moving in the y direction initially over, this is the same amount of time. So that goes here and this mass goes here. And what you find is that you get 3.987 or something, but that you can round up to 4.0 times 10 to the third newtons. But again, this is positive because the momentum increased, but that's because you're looking at it from the perspective of the bat. But if you're looking at it from the perspective of the ball, this ball exerts now a negative force on the system, which would now make that negative 4.0 times 10 to the third newtons. So this is the force in the y direction, that's the force in the x direction. And if you want to express that in vector notation, it would just be 3.3 I for the x minus 4.0 j in the y. And then, of course, all of this is times 10 to the third newtons because you have it's thousands, and you just want to use it so you can simplify the notation. So the force is the force exerted by the ball on the bat is positive when it's going to the right, negative when it's going upwards.